In the first part of this program, we have seen how important the reservoirs are, and we have also seen the three stages of its fertility, namely initial fertility, trophic depression, and final fertility. In this part of the program, we shall deal with the aspect of reservoir productivity, and we shall delve deep into this ecosystem to get familiar with the biotic community thriving there. The productivity of a reservoir depends upon various physico-chemical and morphometric characters like the size and shape of reservoirs. For example, deeper reservoirs are seen to develop blooms of blue-green algae as soon as they are impounded. Such blooms are usually maintained round the year. Shallow reservoirs are usually seen to give poor production of plankton. The location of a reservoir is an important factor which contributes to the productivity. For example, a reservoir situated near granites and gneiss rocks are found to have high phosphorus, nitrogen, and organic carbon content in its sediment, thereby contributing to high productivity. Some other factors in reservoir productivity are water pH, bound carbon dioxide as carbonate, total alkalinity, calcium, and free carbon dioxide. These factors show depth-wise variation. Surface waters often develop high pH value due to photosynthesis, while waters below the zone of effective light penetration show low pH values. In soft water reservoirs, least productivity is met with at a pH range of 4 to 6, bound carbon dioxide as carbonate less than 9 to 10 ppm, that is 9 to 10 parts per million, total alkalinity up to 20 ppm, and calcium content of 10 ppm. In medium water reservoirs, productivity is medium at pH 7, bound carbon dioxide as carbonate at 30 to 35 ppm, total alkalinity at 20 to 90 ppm, and calcium content 10 to 25 ppm. In hard water reservoirs, highest productivity is met with at pH 8.5 and upwards, bound carbon dioxide as carbonate 35 to 40 ppm and reaching up to 200 ppm, total alkalinity greater than 90 ppm, and calcium content greater than 25 ppm. Temperature is an important factor causing thermal stratification in reservoirs. In temperate regions, reservoirs often develop a thermocline with the formation of epilimnion or the upper warm circulating water, metalimnion or the middle layer, and the hypolimnion, the lower colder non-circulating layer of water. Light penetration causes the formation of littoral, limnetic, and aphotic zones in a reservoir. Littoral zone is the shallow water region with light penetrating to the bottom, typically occupied by rooted plants. Limnetic zone is the open water zone to the depth of effective light penetration or compensation level, that is, level at which photosynthesis just balances respiration. The community in this zone is composed of planktons, nectons, and sometimes neuston. This zone is absent in small, shallow reservoirs. The aphotic zone is the bottom, deep water area which is beyond the depth of effective light penetration. The biotic communities in the reservoir consist of the producers and consumers in the various zones. In the littoral zone, the producers are of two types: the rooted or benthic plants belonging to spermatophyta like typha and nymphea, and phytoplanktons comprising mostly of algae like Bacillariaceae, chlorophyta and cyanophyta. The consumers in this zone are of three categories. The primary consumers, consisting mainly of herbivorous forms feeding exclusively on floating, submerged or rooted vegetation like snails of the genus Limnia, zooplankton species like Daphnia and Cymocephalus, and amphibian vertebrate larvae like that of frogs and toads, which are exclusively primary consumers. Secondary consumers are species like dragonfly and damselfly larvae, which are exclusively carnivorous. These may be found resting or moving on the bottom. The amphibious vertebrates like turtles, frogs, and water snakes are exclusively carnivorous. The tertiary consumers, like certain fish species, especially the catfishes and tuna species, represent the end of the food chain. In the limnetic zone, the producers consist of algae of three different groups, chiefly the dinoflagellates, Euglenidae, and Volvocidae, and algae like green flagellates. The primary consumers in this zone consist of species of copepods, cladocerans, and rotifers, which are exclusively herbivorous. The top consumers are some freshwater species of fishes. In the profundal or aphotic zone, the detritus consumers and secondary consumers are met with. The detritus consumers form the major community consisting of bacteria and fungi. The secondary consumers consist of bloodworms, that is, hemoglobin-containing organisms like Chironomus and Chaeoborus larvae. The gradual transformation from riverine to lacustrine ecosystem gives rise to this intricate ecosystem which grows up as a result of an artificial system. Due to this, though reservoirs are useful in several ways, they may often pose great hazards. For meeting his needs, man goes to any extent, and thus he tends to often overlook the negative aspects of things. Where the constructions of dams is concerned, often such steps are taken which may turn out to be great hazards for the future. For example, often dams are built in earthquake-prone areas, while often large areas of fertile agricultural land are lost and large human population displaced. If we may take care that the negative points are kept in mind, then reservoirs may remain the temples of modern India. In this program, thus we find in the reservoirs a fascinating phenomenon, quite like nature's own healing powers, that a river, when suddenly stopped on its way, develops a completely different ecosystem, effecting a gradual transformation from a lotic to a lentic ecosystem.